as we discussed in the previous lesson, what are simple harmonic motion, we also discussed about waves. We discussed about how waves work. We discussed about the different types of waves and everything. The next topic is going to be, the next topic that we're going to study is to be more, you could say, what the right term for it, but more specific to the types of waves that in the previous chapter helped us to understand what waves are, okay? Different types of waves, mechanical and electromagnetic. We further divided it into two, transverse and longitudinal. And then we discussed how transverse waves work, how longitudinal waves work, transverse crust and trough, and longitudinal compression and rarefaction and everything, wavelength, uh, time period, frequency. We discussed about everything. Now we're going to jump into, we're going to go for the next level, that we're going to discuss sound in detail. What sound is, what type of wave it is, and how what are the necessary things to have all the information regarding sound. So let's jump to the introduction of the chapter. The very first point that we need to understand is, okay, how sound is produced, and that sound waves require a material for their propagation. We'll justify it with an example, and describe longitudinal nature of sound. Describe the term pitch and quality and loudness of sound. Describe the effect of change in amplitude on loudness and the effect of change in frequency. Define intensity and its SI unit. This would be something totally new for you. Rest of the things you have an understanding of the topic. Okay. Describe how the noise is nauseous, that is irritating. Describe how reflection of sound may be echo. Reflection of sound is known as echo. So we're going to discuss that in detail in this chapter. We're going to discuss the audible ranges of frequency, importance of acoustic reduction, and solve problems based on this. Okay? That was the Bahawalpur board book, and approximately similar points are given on the other. As we could see, the very first point explain how sound is produced, and that sound requires a material medium for that. Describe how sound is literal in nature. Describe the term pitch. Describe the effect of change in amplitude, SI unit, intensity and its unit. Is sound noise is irritating, echo, audible frequency range, acoustic protection, and mathematical things. So approximately in both of the chapter, the basic information provided by the chapter is same. There might be a difference in detail to these topics, but rest of the things would be fine. Now, let me take you to, let me copy this area and let's make notes of it, and then we'll get to the reading of this chapter. Okay. The very first thing that they have described here is how sound is produced. How sound is produced. Acha, let's leave that. Let me get back into it. Whenever it comes to sound, sound is produced by vibrating source and requires a medium for its propagation. Two major things. What? Okay, whenever there would be sound, we need a vibrating source for it, and we need a media for that. So if someone would ask us how can you produce sound, these 2 points must be mentioned here. Now, to justify that we are dependent on media, we take help from an example that is given in our book, that there might be this, yes, this example. In the following example, we have a jar. We have, can you see the red spot moving across the screen?
Yes.
Oh. Now, we have a jar, we have a vacuum pump, we have an electric bell. Now, with this experiment, we'll be able to justify that sound requires medium for its propagation, and without the medium present, sound cannot travel. So we have this glass jar present. Initially, we'll turn on the bell and we'll be able to hear the sound of the bell. And after some time, we'll start pumping out the air out of the jar, and we'll observe that the sound is getting faint and faint and faint, and eventually there will come a point when all of the air from the glass jar is removed. We would not be able to hear any sound, but the bell would still be ringing. So that proves the point that sound requires medium for its propagation. So, what were the two things that we need to keep in our mind? That to produce sound, we need a vibrating source and we need a medium. And whenever asked, how would we justify or prove that sound is dependent on a medium, we would take help from this example and we'll write the theory alongside it. With that, we'll take a glass jar with air in it and attach to a vacuum pump. And we'll turn on the vacuum pump. Eventually, the sound will get faint, and there would come a point when we'll be able to hear no sound. And the reason behind that is because all of the air from the jar is pumped out, showing that there is no medium present through which sound could travel. So we'll not be able to hear any sound out of it. Clear?
Yes.
Yes.
Let's get to the second point. Now, sound is longitudinal in nature, which means it would travel in the form of what? What is meant by longitudinal?
It travels in the form of compressions and rarefactions.
Yes, it comprises of compression and rarefaction, and it travels in a straight line. You might have observed sometime that if you're going on a road and there's some kind of a sound source right in front of it, if you'll be right behind it, you'll be able to hear a very loud sound. But when you'll bypass it, the sound would get fainter, which means is fainting and fainter is even a word. I'm just making it up.
Fainter is a word, not fainting.
Is a word. Fainting to nahi, fainter. Before you judge me, I just asked from you guys that is this even a word or not? So the sound is longitudinal in nature, which means it will travel in the form of compression and rarefaction. Compression is the compressed part of the wave, and rarefaction is the stretched part of the wave. How can we show compression and rarefaction? There are two waves, one like this. This is compression, and this is rarefaction. Second way is to draw like perpendicular bars. Oh, so the areas which are closer, these are compression, rarefaction, compression. And from one compression to next compression is one wavelength. Where do I need to end this line? Should I stop at the first wavefront or the second wavefront? For one wavelength.
What do you mean?
Hareem.
I didn't understand your question.
I'm asking K, should I stop at the first wavefront to show one wavelength or to the second wavefront to show one wavelength? I have started from the second wavefront here. I started from this point now. So where should I end to show one wavelength?
The last. No, wait.
I
From the
told you
start
guys
till
that
the
from
end.
no. For example, if I've started from the second wavefront of the compression, I would end at the second compression of the wavefront. That would be one wavelength. If I started from the first wavefront, I would end at the first wavefront, that would show one wavelength. If I started from the last wavefront, I would end on the last wavefront to show one wavelength. We need to be careful with these things. Okay?
Okay.
Did you get my point, Hareem?
Yes.
Okay. The next thing that we're going to study is this is one wavelength. Describe the term pitch, loudness, and quality of sound. Okay. There are three things which is associated with sound, and that is pitch. We have loudness. Let's do it one by one. Pitch, it is dependent on the frequency of sound. Okay, which means less wavelength, greater frequency. And what effect would it have on the sound? A high pitched sound is more squeaky. Okay? And we say shrill and grave. The squeaky sounds are high pitched, and normally children's and women's have high pitched sound. Whereas grave sounds, men mostly have grave sound. It means they have low pitch. Low pitch means low frequency, which means greater wavelength. So if they have shown us two wavefronts, two wavelengths like this and like this, which would have a greater pitch?
The lower one.
Okay, so this is low pitch, which means grave sound. Grave sound means heavy sound. Normally men's have heavy sounds. And high pitch. Do you understand the meaning of pitch? What does pitch means?
Yes.
It tells us how shrill or grave sound is. Pitch determines how grave or shrill sound is. Now, the second thing, which is loudness. Loudness depends on amplitude. And we have discussed amplitude. Amplitude is defined as the maximum displacement of the wave. So, depends on amplitude, and it tells us how loud or faint sound is. So if I draw two waves like this, and like I need to draw in comparison to it, and I draw another wave like this, which would be loud and which would be why it got raised. Yes, which one would be loud and which would be faint? This would be faint, this would be loud. Why is that? Greater amplitude and its opposite, less amplitude. And there's one thing that you need to keep in your mind, that there is no relation between an amplitude. There is no relation between pitch and amplitude. So if there is a question there where they ask us what would happen to the loudness of sound and if the pitch is changed, so what would be our answer?
It
It
would
would
remain.
have no effect on
Yes,
it.
it would have no effect on it because there is no relation between the pitch and the amplitude. Clear? And the last thing is
Yes.
quality of sound. Quality of sound, and the last topic of today's lecture is it help us to distinguish between different sounds. There's a term used as timbre, which is normally signifies with the quality of sound. For example, if a piano and a guitar is playing in one room, we would be able to distinguish between them. And why is that? It is on the basis of the quality of the sound, because they would have a different quality of sounds that would help us to distinguish between these two. And I would like to add one small topic into this lecture of today's lecture, that is the audible frequency range. Audible frequency range for a normal human being is 20 hertz to 20,000 hertz. Sound below 20 hertz would be infrasound, and sound above 20 hertz would be ultrasound. And we're going to discuss the uses of it in the later stages. Am I clear up till now?
Yes.
Okay. So initially they have discussed the nature of sound, which is clearly we know we have discussed that it's longitudinal in nature, and longitudinal transfers are mechanical waves, and mechanical waves means they are medium dependent. So initially they have discussed that the sound is mechanical in nature, and they requires medium for their propagation. And we have discussed in context to the example as well. The waves are basically combination of compression and reflection. We have discussed that as well. And in the last paragraph, they have obviously discussed the nature of wave, because it's a wave, so it would transfer energy without transmitting any medium. So there's this one point that we need to keep in our mind when it comes to that, as sound is material dependent, so sound would travel fastest in which medium? Solid, liquid, or gas?
Solid.
Then liquid, then gas. Because the particles are most dense in solid, then liquid, then gas. Speed of sound is maximum in solid, then liquid, then gas. The next thing that they have discussed is source of sound. The object, which is basically the cause of vibration, is called the source of sound. In our case, our vocal cord is the source of sound. In case of guitar, the strings are the source of sound. In case of they have so many examples there. Acha, speed of sound is it has exactly the same formula that we have studied in the previous chapter. What is the formula for speed of sound? Distance over time. Okay? Distance will calculate, time will calculate, we'll put it into the equation and we'll get the formula. So normally the speed of sound in air is taken as 332 meters per second, and it increases in solid and liquids. You could see the formulas here. Distance by sound wave divided by time taken. And they have given us the two factors on which the speed of sound is dependent, of the and the intermolecular distance. Then we have sound travel. वो जो मैंने अभी आपको बताया कि much faster in solid than liquid and gases, because of the intermolecular distance is very small and density of solid is greater than liquid and gas. मुझे थोड़ा सा डाउट था कि मे बी इंटरमोलिकुलर डिस्टेंस समझ में ना आया, बट नेक्स्ट टाइम में आपको बता दिया कि इंटरमोलिकुलर डिस्टेंस बेसिकली द डिस्टेंस बिटवीन द molecules. In vacuums, there is no existence of atoms, so there would be no sound traveling across it. Example, we'll come back to it. How sound is produced? So हमने क्या discuss किया था? It needs a vibrating source and a medium. So here it is a vibrating source and the medium. That's how sound is produced. They have used a tuning fork here. Tuning fork is an apparatus through which frequency of vibrations are produced. When they are brought close to the glass jar, the water would splash out of it, showing that the tuning fork is vibrating. And with the help of that, we're able to hear the sound or see the frequency of vibration down. Here they have justified. In which position of vibrating tuning fork, sound can be heard due to vibrations of free tuning fork with the particles of the medium. When we bring this tuning fork closer to our ear, now we're able to hear the vibrations and the sound. A very feeble sound, but we are able to hear it because the frequency is very low, so हमें sound इतना clear नहीं सुनाई देता. But it is one of the operators which is used to produce and to see or study the properties of sound when we go to experimentations. Now, you might do the experiment using the tuning fork in which you would find out the speed of sound. And then we have medium for propagation of sound, वो हम लोगों ने discuss कर लिया हुआ है with the help of this class. Nature of sound हमने discuss its that is longitudinal in nature. It travels in the form of compressions and rarefactions. And हाँ एक और चीज भी है. Since we have discussed that it is medium dependent, so it is also dependent on the kinetic energy of the particles. So if the kinetic energy of the particles is greater, sound will travel faster. If the kinetic energy of the particles are low, that is in a colder system, the sound would travel slow as compared to the one which is at a greater temperature. So वो भी एक role play करता है उसके अंदर. ठीक है?
Okay.
Okay.
अब यहाँ पे उसने डिस्कस किया हुआ है कि मॉलिक्यूल्स ऑफ द मीडियम ट्रांसफर अकॉर्ड काइनेटिक एनर्जी टू द नेक्स्ट मॉलिक्यूल ऑफ द मीडियम. उन्होंने यहाँ पे एक अच्छी एग्जांपल भी दी हुई है कि जो पार्टिकल्स राइट इन फ्रंट ऑफ द ट्यूनिंग फोक होंगे, द एयर पार्टिकल्स वुड बी मोर कॉम्प्रेस, सो यहाँ पे डेंसिटी ज्यादा होगी. इट वुड शेयर तो दिस इज अ रेयरफेक्शन एंड compression and rarefaction. So the air particles that are right in front of the tuning forks, it would have compressions, and the ones which are on the other side, they would have reflection into it. Lest you guys could read this and you would be able to understand everything. Infrasound and ultrasound, they have mentioned here. मैंने आपको पहले बता दिया कि जो 20 hertz से below sound है, that's infra, and above 20 hertz is known as ultrasonic sound or ultrasound. In either way, you could go with that. You might not need to memorize all the values that they have given here कि ये sound ये है, but normally just keep this in your mind कि इस तरीके से values हमारे पास होती है. Echolocations and echo systems जो हैं, वो these are the properties of sound that we are going to application, you could say application of sound we're going to study in the later part. Wavelength, amplitude, I have explained to you in the beginning. Characteristics, pitch and frequency, I have explained to you in detail. And देखिए हमने एक टेबल में comparisons build किए हुए कि loudness is the property of the sound which is differentiating between the loud and faint sound, or shrill and grave sound, flat sound. The pitch is used differentiating between both. Loudness is dependent upon the energy received by the user in time interval, and pitch is independent of the energy received by air in unit time. As I told you, there is no relationship between sound and pitch. Loudness is independent of the change in frequency, and pitch is dependent on the change on the frequency. It is dependent. There are a few more factors on which loudness depends upon. This is a long question. It might come in the exam. Vibrational amplitude of source sound, surface area of the source of sound, distance from the source of sound, and the sensitivity of ears of the listener. The headings are pretty much explaining everything. We do not need to get into details of that. The heading is basically explaining everything, that how loudness depends on these factors. Obviously, the greater the surface area, greater would be the loudness of sound, and how greater the distance from the source of sound, loudness would get weaker, and obviously sensitivity also affects the soundness. Quality and timbre, I've explained to you. It is that characteristics of sound which helps our ear to distinguish between two sounds which have the same loudness and pitch. Quality is also called timbre. Rest you could eat it on your own. And we are done up till here. We'll resume from intensity of sound form for tomorrow. Okay. And when it comes to intensity of sound, the thing that we need to keep in our mind is okay, what is the formula of intensity of sound, and कौन से parameters है on which the intensity of sound depends upon, and the last thing that we need to keep in our mind is कि उसका formula क्या होता है, उसके parameters क्या होता है. So intensity is basically defined as power per unit area. The book is opening. It's a long question. It's first one of the long question. Okay. Intensity is defined as the energy transmitted by sound wave per unit particular area per unit time is called intensity of sound, or we could simply say intensity is power per unit area. फॉर्मुलेशंस तो ऑब्वियसली आपको आती होंगी कि पावर का फॉर्मूला किसके इक्वल होता है. पावर इज इक्वल टू एनर्जी ओवर टाइम. ठीक है. सो एनर्जी पर यूनिट टाइम इज पावर over area. So power is what is the unit of power? It's watts, and area has meter square. So intensity has a unit of watts per meter square. In terms of relationship between intensity and amplitude of sound can be studied as change in amplitude developed by pressure divided by 2 into density of medium into speed of sound. So the relationship between intensity and amplitude is given as change in amplitude. Here A is representing amplitude, not the area. Okay? Change in amplitude developed by the pressure square divided by 2 into density into velocity of sound. Loudness and intensity का relationship जो होता है, what is the difference between two? It is subjective in nature. It is objective in nature. Sorry, by mistake हो गया. It is not completely a physical quantity, whereas intensity is a physical quantity. It depends upon the sensitivity of air. It does not depend on the sensitivity of air. Loudness has a unit of decibel, and intensity has a unit of watts per meter square. So whenever the intensity of sound would come, first you need to write the definition, the formula, the relationship between intensity and amplitude. Normally, when we deal with the MCQs, now we simply say that intensity has a direct relationship with the amplitude square. बाकी ये सब कुछ, ये जो फैक्टर्स हैं ना हमारे पास, नॉर्मली हम इनको इग्नोर करते हैं, बिकॉज डेंसिटी एंड स्पीड जो है वो और स्पीड ऑफ साउंड इन द मीडिया जो है अप्रोक्सीमेटली सेम रहता है, तो हम इन फैक्टर्स को फॉर द टाइम बीइंग इग्नोर करते हैं. Whenever it comes to intensity, we normally deal with intensity is directly proportional to the amplitude square, as written in the formula as well. Change in amplitude, its derivation is not important in your coursework, so just keep that in your mind whenever we do with this. Now, the next thing is sound intensity level. Loudness is directly proportional to the log of intensity. When we remove the intensity proportionality sign to get a constant K. Similarly, this was louder sound and faintest sound के लिए हम जब relationship करेंगे फिर उसका आपस में हम लोग ratio find out करेंगे and we'll put this into the equation and we will have a constant, उसकी values के ऊपर हम लोग बात करेंगे. Quality of sound के अंदर हमारे पास वो चीज है. It is quantity which describes the amount the sound level produced by any sound source and compares with the standard fixed value. Sound intensity level के लिए हम लोग we need that is के so हम क्या what could be the right word for you? एक standard source होता है and the other is our source of sound. हम उन दोनों को compare करते हैं with the help of their values. अब उन्होंने ये बोला it has no units cause उसका मैंने आपको बताया ना वो ratios जब आती हैं तो units cancel out हो जाएंगे उसके अंदर. When we compare the intensities, आपने मैथ्स में लॉग के रूल्स पढ़े थे ना? We know that के जब माइनस होता है it means कि वो आपस में क्या हो रहे हैं?
Yes, we've done it.
डिवाइड हो रहे हैं.
Divide.
ठीक है, तो इस वजह से वो यूनिटलेस क्वांटिटी होती है. उसने स्टार्ट में एक्सप्लेन कर दिया. इट हैज नो यूनिट्स एंड रीजन मैंने आपको अभी डिस्क्राइब कर दिया बिकॉज हम उसको लॉग का क्वांटिटी ले रहे हैं. लॉग का जब हम लोग करेंगे तो वो आगे से बोला हुआ है कि when we compare intensity of such two sound waves which has same frequency, we take the ratio of powers of sound waves. Let us consider there are two intensities of sound, I and I naught. इनमें से एक ओरिजिनल साउंड होगा और एक सोर्स साउंड होगा. ओरिजिनल साउंड का मीन्स कि जिस तरह हमारे पास स्टैंडर्ड साउंड होता है एक वो होगा I नॉट एंड I किसको रिप्रेजेंट कर रहा होगा जिसको हमने कंपेयर करना है उसके साथ. And their loudness are L and L naught, respectively. Loudness of sound is directly proportional to the logarithm of intensity and is given by L is equals to O and this vector. And similarly for L, I naught and L naught equation would be like this. हम इन दोनों का जब डिफरेंस लेंगे L minus L naught, this would be equals to K into log I minus O. K into log common ले लेंगे and minus ka sign indicates that it would go into the fractional parts and in respective units. So the difference in the loudness of two sounds is called the sound intensity level and is represented by beta. And the equation is written as where आगे उन्होंने वही बोला कि I जो है वो high sound intensity को show कर रहा है and I not इसको show कर रहा है faintest sound intensity. जो हाईएस्ट साउंड इंटेंसिटी होती है उसकी स्टैंडर्ड वैल्यू 1 वॉट्स पर मीटर स्क्वायर होती है. फेंटेस्ट की 10 इंफ्रारेड पर -12. वो होती हैं फिक्स वैल्यूज होती है हमारे पास. ठीक है, if intensity I of unknown sound is 10 times greater than the intensity of I naught, the faintest audible sound, that is I is equals to 10 of I naught लिखना था यहाँ पर वो मिस हो गया हमसे. And intensity level such a sound given as bell, the value of k becomes 1. अब आप जब वो log of 10 आप लेते हो आपको पता है ना log 10 की वैल्यू किसकी इक्वल होती है?
1.
1 के. तो वही बात होनी है. So intensity level beta is equals to log I over I naught and अगर हम उसका 10 log ले लेंगे it would be decibel. We know ये उन्होंने वो यूनिट्स उसके डेसी किसके बराबर होता है 10 raised to the power -1 के. तो 1 पहले is equals to 10 decimal. ये आप हमारे जो कह सकते हैं लोगों ने जो प्रीफिक्सेस पढ़े थे उसको that has used this equation. The unit of intensity is decibel. वो हम लोगों ने पहले भी पढ़ लिया. And जिसकी बेसिस सच अ स्केल जिसके ऊपर हम इंटेंसिटी ऑफ साउंड्स को डिस्कस करते हैं वो डेसिबल स्केल होता है. Here is one of the question. How high a sound will be if it's 4 times as intense as the first sound? So intensity of first sound is I. Intensity of second sound is 4I. रेशियो हमारे पास किसका होता है? लाउड ओवर उसका होता है या किसका रेशियो होता है हमारे? आई ओवर आई नोट था ना.
Yes.
Yeah.
ठीक है, सो इंटेंसिटी ऑफ सेकंड साउंड टॉप न्यूमरेटर में आएगा या इंटेंसिटी ऑफ फर्स्ट साउंड न्यूमरेटर में आएगा?
Second.
ठीक है, बिकॉज आई रिप्रेजेंट कर रहा होता है उस साउंड को जिसको हमने अंडर कंसिडरेशन रखना होता है, और आई नॉट ओरिजिनल सैंपल को डिस्कस कर रहा होता है। तो 4i ओवर आई, आई कैंसिल आउट हो जाएगा, 10 log 4 जो भी आंसर आएगा उसकी वैल्यू में। अब 6.02 डेसिबल की वैल्यू किसको शो कर रही होती है, किस साउंड को शो करेगी? मतलब इट वुड बी बिटवीन 0 and 10 डेसिमल में होगा, तो इससे हमें पता लगेगा कि ब्रीदिंग की साउंड हो सकती है एट मोस्ट। बाकी जो फैक्टर्स थे ये हम लोगों ने लास्ट टाइम भी डिस्कस कर लिए हुए थे, कि जो स्पीड ऑफ साउंड है दैट वुड डिपेंड अपॉन द टेम्परेचर ऑफ द मीडियम, डायनामिक कंडीशंस ऑफ द मीडियम, डेंसिटीज वगैरह, विस्कोसिटी ऑफ द मीडियम, एंड दैट्स इट। अब ऑब्वियसली टेम्परेचर इंक्रीज होने, टेम्परेचर से इंटेंसिटी ऑफ साउंड का क्या रिलेशनशिप होगा? What would the relation between temperature and the speed of sound? Because when the temperature would, when the temperature would increase, so the kinetic energy of the particles, so the speed of sound or the energy transferred by the particles would be high. Whereas, viscosity से क्या effect पड़ेगा? The more viscous the substance is, the speed of sound would be greater. ठीक है? And this is the relationship that you're going to study in the senior classes. Vt is equal to V naught plus 0. With every degree C rise in temperature, the speed of sound increases by a factor of 6, 0.6. लिखा भी होगा यहाँ पे. Speed of sound increases with increase in temperature. For example, by 1 degree rise in temperature, speed of increases by 0.61. And the equation that we use is, and V naught शो करा है टेम्परेचर एट स्टैंडर्ड टेम्परेचर एंड प्रेशर, रूम टेम्परेचर की वैल्यू को शो करा था 332। हमने बिल्कुल स्टार्ट में इसको पढ़ा हुआ। Speed of sound can further be supported by dynamic state of the substance. For example, if wind is blowing with high speed, it will help to transport sound more effectively as compared to slow wind. Whereas viscosity, speed of sound does not depend upon viscosity of the medium. The term viscosity tells about the resistance. अच्छा, यहाँ पे उस रेजिस्टेंस में बात करें, मैं विस्कोसिटी का एक टर्म उसमें भी यूज होता है, मोर विस्कस लिक्विड, लेस विस्कस लिक्विड, बट यहाँ पे वो इन टर्म्स ऑफ उसकी रेजिस्टेंस शो पे बात कर रहा है। एनी हाउ, the speed of sound does not depend upon the viscosity of substance. The term viscosity tells about the resistance of the medium to change the movement of nearest molecule of the medium. So independent of viscosity and directly proportional to the डायनामिक कंडीशंस हो। इसमें यहाँ पे मैंने प्रेशर को नहीं डिस्कस किया हुआ, प्रेशर एंड डेंसिटी। डेंसिटी को हम लोगों ने चूंकि शायद आई गेस स्टार्ट में डिस्कस कर लिया था, इस वजह से हमने उस चीज को मेंशन आउट नहीं किया हुआ। नॉइज को कैसे डिफाइन करते हैं? हाउ डू वी डिफाइन नॉइज? Generally, if someone would ask you what is noise, what would be your answer?
Unwanted sound.
हाँ जी, जो अनवांटेड साउंड होती है दैट इज नोन एज नॉइज, और वो हमारी उसके ऊपर जो है नेगेटिव इफेक्ट जो है वो प्रोड्यूस करती है। तो पीरियोडिक साउंड वेव्स तो हम लोगों ने पीरियोडिक का टर्म पढ़ लिया था ना, पीरियोडिक का मीनिंग क्या होता है?
Yes.
पीरियोडिक वेव्स जनरली क्या होती है? हाउ डू वी डिफाइन पीरियोडिक वेव?
Repeating waves.
यस, रेगुलर इंटरवल टाइम। और रेंज ऑफ फ्रीक्वेंसी हमारे पास क्या होती है फॉर नॉर्मल ह्यूमन एयर्स?
20 hertz to
20 to
30,000 hertz.
20,000.
What question are you? Yes. So in general, the term noise means unpleasant sound waves experienced by a listener. But in physics, noise has the following characteristics. Noise has a non-rhythmic behavior, मतलब periodic motion नहीं होगा उसका. Graphical wave of noise shows variable energy states. Waveforms in graph of noise indicates that it possesses multiple range of frequencies, and graphical representation shows irregular intensity distribution of sound. So if the question comes, how would you justify that the following sound is noise? तो हम कहेंगे उसका non-rhythmic behavior होगा. It would show multiple energy states, multiple frequency ranges, and irregular intensity distribution. As you could see here.
Okay.
वेरिएबल एनर्जी स्टेट्स हैं, हमारे पास इंटेंसिटी लेवल्स वेरी कर रहे हैं. ये म्यूजिकल साउंड है, बट इसकी कांस्टेंट एनर्जी स्टेट्स हैं हमारे पास. ठीक है, मतलब रिपीट हो रहे हैं आफ्टर रेगुलर इंटरवल ऑफ टाइम. So that would not be considered as noise. नेक्स्ट इसने को बेसिक बात ही की भी है. बाकी से नॉइज के एडवर्स इफेक्ट्स बताए हुए हैं कि using earplugs, turning off appliances when not in use, planting more trees, lowering the volume, regular maintenance of vehicle and machines, and by controlling noise, we can control the negative health effect that noise pollution has on everyone. I think so that's it for today. We have discussed the following topics today, that intensity is equals to power per unit area. We have discussed that intensity is equals to energy per unit time per unit area, and this is equals to power. So from there, we discussed that intensity is directly proportional to amplitude square, or intensity is also equals to the amplitude square over 2 into density into speed. Then we discussed the formula. Intensity level scale था, क्या था वो point? I forgot the word. Intensity level ही था.
Intensity level.
हाँ,
Sound
it's equals
intensity
to
level.
K log I, and L naught is equals to K log I naught. We subtracted it from each other. K common ले लिया था. Log I minus log I naught. Minus sign indicates that it would divide. L minus L naught is equals to K log I over I naught. And this is equals to beta K log I over I naught. Then हम लोगों ने क्या डिस्कस किया? What did we discuss after this? What for the next point to discuss?
The factors which affect the sound waves, like their propagation, temperature, velocity.
Dynamic conditions. And out of these two, temperature is directly proportional. Pressure, density को हम लोग बिल्कुल start में discuss कर चुके हैं कि sound has a direct relationship with the intensity. Intensity कह रहा हूँ, temperature. So speed is directly proportional to temperature. Speed is directly proportional to density of the substance. Speed is proportional to, or speed depends on the dynamic condition of the material and is independent of the viscosity. And at the last, what we discussed about the points?
Noise.
Noise. What are the 4 conditions that क्या हमारे पास क्या होगा? Noise non-rhythmic होगा. Multiple energy states होंगे. And multiple frequency range होगा. And what was the last point?
Irregular intensity distribution.
Last was irregular intensity distribution. Noise को 2 ways में explain कर सकते हैं. Unwanted sound, or in physics, we need to keep into account these following 4 points. That's it for today.